Welcome back. Since our last talk, we've made good progress on our mission to replace heavy cables in satellites with optical communication. For any new viewers, this is OC4SAT, an EU research and development project which aims to simplify satellite architecture by replacing bulky, complicated wiring harnesses with LEDs and cameras. Check out our other videos for more information. We've been running computer simulations of the way light bounces around in the satellite internals, but to truly test our idea, we had to build it for real.
Hi, I'm Marco Giuliani, an R&D project manager of Argotec, one of the members of the consortium for SEC4SAT. We are responsible for building the mockups and integrating and testing the system for its validation. The satellite mockups are built in-house with the same processes and materials we use for our real-world satellites. We machine them in-house with our CNC, and they are designed to be both lightweight and durable. This kind of hardware, we use our own robot arm inside our clean room. We use it to torque hundreds of bolts on each of our satellites in order to torque them to the correct specification and ensure that human error and any potential imperfection is not a cause of failure. We encountered a couple of interesting problems while working on our satellite mockups. For example, the way we machine the parts with our CNC leave visible tool marks that do not affect mechanical properties of the components and that are fine for our satellites, but they affect the way that the light is reflected, and it is a big impact on the OCC system and its performance. For this reason, it's important to simulate it properly and to understand the phenomenon so that we can understand how the system works and how to enhance the performance. Fortunately, this has an easy solution. We managed to perform bead blasting on top of the aluminum part so that we can give a homogeneous and specific texture to the components so that the light is reflected homogeneously. Working on the mockup has been really interesting. It's very rewarding to see how the CAD files on our computers become real-world objects that we have in our labs.
This is Matteo Pontecorvo. He's another scientist at Argotec and will be handling test assembly of the satellite. Ordinarily, this kind of work would be performed in a clean room, but that's unnecessary for a test bed like this. The satellite is designed as a modular kit of pieces, sort of like Lego. Everything is held together with bolts, meaning that it's easy to disassemble it, swapping out components or altering the internal layout. We're most likely going to need to do this many times during the course of development, as we compare real-world performance of different layouts to our computer simulations. This will let us refine our models and figure out what new satellite architectures are possible with this technology. So, where do we go from here? Testing with this mock-up will let us finalize the design of our signaling protocols and begin work on production hardware. Once we have confirmation our architecture performs well in the real world, we're going to focus on making the technology scalable and ready for mass production. We plan to use this project to validate the technology before making it space-grade for future launches. Thanks for sticking with us on this project. To find out more about OC4SAT and get updates on our progress, you can subscribe to this channel or follow us on social media. We'll have more content for you soon. Thanks to Argotec for providing footage of their facilities for this video.